All right, good afternoon, everyone. I decided to make this quick video for those of you that did not do as well on the quiz earlier today as you wanted to. You can certainly rewrite a similar quiz. It would be probably 6, 7, or 8 multiple choice numerical response questions, and that would take place in my classroom tomorrow at lunch. And by tomorrow, I'm talking about Wednesday, December 8th. So let's go through these questions one at a time. Number 1 gives you a graph of a rational function, and you're told that it's a function of the form f of x equals a over x minus h, then plus k. So you should recognize that what's happening here is that you are going from a function of y equals 1 over x, and you're transforming it into y equals a over x minus h, and then plus k. So you need to recognize, this is an x, you need to recognize that we're going to have a shift because of h, and that shift will be horizontal. We're going to take y equals 1 over x, we're also going to shift it or translate it vertically, and that vertical shift is going to be indicated by the value of k. And then a is a vertical stretch factor, and possibly, but not in this case, possibly it could be responsible for a vertical reflection. If you take a look at the original graph of y equals 1 over x, because that's what we are transforming, the original graph of 1 over x is a graph that you should be familiar with. You should know that it has both axes as being asymptotes, and it's that set of curves which we call a hyperbola, with one of these curves in quadrant 1 and one of these curves in quadrant 3. And what we were taught in class is that no matter what happens with the vertical stretch factor, no matter what a is not going to affect the location of those asymptotes. The only thing that can change the location of those asymptotes after a is applied is we're going to take the whole graph, asymptotes included, and translate it horizontally and or vertically. And when we look at where the asymptotes are on the function whose equation we are trying to figure out, we can see that there's a horizontal asymptote at y equals 4. But the horizontal asymptote of 1 over x is y equals 0. So the only explanation there is that k on this graph must be equal to 4. We're shifting the entire graph that I've drawn, which is 1 over x, we're shifting it 4 units up, which means k is 4. Similarly, when we take a look at where the vertical asymptote is on the graph whose equation we're trying to find, that's this asymptote. This asymptote is at x equals 2, but the original asymptote before any translations occurred was x equals 0. So the only thing that makes sense here is we've shifted that entire graph, y equals 1 over x. At some point, we've shifted it 2 to the right, which means h is equal to 2. Now, how do you go about finding a from this point on? There is a shortcut. I'm not going to explain the shortcut on the video. I'm going to go to the tried and true algebraic method, which is to write the equation that we've developed so far by putting our parameters into our template. Our template is y equals a over x minus h plus k. So I've put the value of h equals 2 and the value of k equals 4 into that template. And now what we have, and I think if I were to go back in time, I'm pretty sure I talked about this on day 1 or day 2 of this course. What we have is a missing parameter. You need to know the value of the parameter a, and to determine the value of the parameter a, you need to substitute into the equation, load into the equation for x and y, an ordered pair. In other words, the coordinates for a point that's on the graph of the function whose equation we want. And up at the top here, there's a point. So the coordinates of that point are 3 for an x coordinate and what looks to be 7 for a y coordinate. So when x is 3, y is 7. Well, that means when I put x equals 3 into this equation, I have to get y equals 7. So my equation is going to become 7 equals a over 3 minus 2, and then plus 4. So I end up with 7 equals, we lucked out here because 3 minus 2 is 1. A over 1 is simply a. We end up with 7 equals a plus 4. So now we know a is equal to 3. And we can take that 3 and toss it back into this equation to get our final answer of y equals 3, which is the value of a, over x minus 2, 2 being the value of h, plus 4, which is the value of k. So you wanted the values of a, h, and k in that order. A is 3, h is 2, and k is 4. And that's the answer to question 1. There is a way that you could have determined that a is 3 by looking directly at the graph, but again, I'm not going to explain this in this video. Number 2, the true statement about a quadratic function. Well, everything that we did dealing with quadratic functions culminated in the fact that you can't tell what's going on unless everything is factored. So when we look at g of x equals x plus 3 over x squared plus, my mistake, over x squared minus 9, x squared minus 9 factors into x plus 3, x minus 3. So we have learned that if you have a factor that cancels, like x plus 3, and this isn't directly relevant to this question, but when you have x plus 3 on the top and the bottom canceling, that means you're going to have a hole at the 0 of that factor that cancels. So we have a hole at negative 3. We've learned that if you have a lone factor in the denominator, and I'm just going to highlight it, in this particular case, our lone factor in the denominator is x minus 3. That factor is responsible for a vertical asymptote. So we've got the question half beat right now. We know that there is a vertical asymptote at x equals 3. Of course, on an exam, you wouldn't do some kind of goofy abbreviation like that. You would write it out. So we have a vertical asymptote at x equals 3. I guess we can strike choice A from the list and choice C from the list. Now, what about the horizontal asymptote? The horizontal asymptote is found by looking at the degree of the numerator and the degree of the denominator. And the degree of the numerator in this particular rational function is 1, and the degree of the denominator is 2. The degree of the numerator is 1 because the numerator is a linear function. The degree of the denominator is 2 because it's quadratic. And you've learned that if the degree in the numerator is smaller than the degree in the denominator, then you are going to have a horizontal asymptote at the x-axis, which is y equals 0. So the correct answer to number 2 is D. Number 3, you're asked for the coordinates of the point of discontinuity of a function. Nobody has any difficulty finding the x-coordinate, but for some reason this is always a question on an exam that stumps people in terms of the y-coordinate. When we factor this rational function, we have f of x equals x squared minus 2x minus 24. So I suppose we're looking for two numbers that multiply to give negative 24 and add to give negative 2. A little bit of brain work tells us the numbers are negative 6 and 4. The denominator, I have a common factor of 2 that I can factor out of that binomial and be left with x minus 6, which means that the two factors that cancel are x minus 6, and that means that the whole will be at 6 comma something. Let me rewrite this now. We're left with f of x is equal to x plus 4 over 2, and we do have the restriction that x cannot equal 6. I really want to drive that point home. It's not relevant to this question, but just because we canceled the x minus 6 doesn't mean that there isn't a non-permissible value for the function at x equals 6. It's still on the graph going to correspond to, well, nothing. In this case, the nothing is a whole. But what I've taught you is, even though you're not allowed to use that non-permissible value, you're not allowed to calculate f of 6 because you can't use x equals 6. I've taught you that if you find f of 6, what you're finding is the y-coordinate, 6 plus 4 is 10, divided by 2 is 5. You're finding the y-coordinate that isn't there when the x-coordinate, which is 6, isn't there. In other words, and that's a very convoluted way to describe it, you're finding the y-coordinate of the point that doesn't exist because you used an x-coordinate of a point that doesn't exist. So the answer to this question is 6, 5. Sally has a rational function. She's told a number of things about this rational function and asked to determine them. So what is the equation of the vertical asymptote? Well, you're going to have to factor this. You're going to have to look at the factors in the numerator and denominator. I'm going to double check my work here. I was just going on autopilot there. Negative 8 times 4 is negative 32, and negative 8 plus 4 is negative 4. The top is factored correctly. 4 times negative 2 is negative 8, and 4 plus negative 2 is positive 2, also factored correctly. What we see is that the x plus 4's cancel, which means we have a whole at the 0 of that factor. We see that the x minus 2 does not cancel with anything. The x minus 2 is a lone denominator factor, and that means we have a vertical asymptote at x equals 2. By the way, and I'll get back to the question in a second, the fact that you have a lone factor of x minus 8 in the numerator means you have an x-intercept equal to the 0 of that factor. So, in fact, I think we have 2 of the 4 things that we're trying to find. The vertical asymptote is at x equals a, and we said it's at x equals 2. So a is 2. We haven't found the horizontal asymptote yet. I'll talk about that in a second. We have found the x-intercept. The x-intercept is 8, so c is 8. And we haven't found the y-intercept. Well, let's start with the y-intercept. How do you find a y-intercept? You find a y-intercept by replacing every x with 0. I think it's pretty clear you're going to be left with negative 32 over negative 8. But if you show your substitution, it's 0 squared minus 4 times 0 minus 8 over 0 squared plus 2 times 0 minus 8. I misspoke a second ago. This should be minus 32. What you are going to be left with on the top is negative 32. On the bottom, you're going to be left with negative 8, which means that f of 0 is going to give you negative 32 over negative 8, which is 4. So we found the y-intercept, which is d, to be 4. The horizontal asymptote is found by using the rules that we learned on Monday, and that rule set in this case asks us to compare the coefficients in the numerator and denominator because the degree in the numerator and the degree in the denominator are the same. And when they're the same, the horizontal asymptote is at y equals the ratio of the coefficients of the highest degree terms. Numerator coefficient of the highest degree term over denominator. And that makes it y equals 1, so b is 1. Number 5 gives you a rational function, and it looks like a case where we have 5 different statements and we're asked how many, not even how many, we're asked which of the statements are true. And in fact, this is a bit of a frustrating thing because I'm not telling you whether 2 are true or 3 are true or 4 are true. I'm not telling you how many. But again, the key in analyzing a rational function is to look at the function in factored form. Now I'm just going to do this bottom part up here because it's going to require 2 stages. The bottom, I can factor a 2 out and be left with x squared plus x minus 20. So the bottom of this is 2 times x squared plus x minus 20, which can be factored. That factors into x plus 5, x minus 4. Now it's really tempting at this point in time to say, you know what, maybe I made a mistake. Maybe that should be x plus 4, and that means there's going to be a hole somewhere. Or maybe the top should be x minus 4. Maybe I wrote the question down incorrectly. But just take a breath, ask yourself if you've factored everything correctly. This, we're looking when we factor it at 2 numbers that multiply to give negative 20 and add to give 1. And those numbers are positive 5 and negative 4. So what I have written at the bottom of the screen is correct. And what that means is nothing cancels. And what that means is there is no hole anywhere. There's no point of discontinuity. Now let's run through the other choices. Is there a vertical asymptote at x equals 4? The answer to that question is a resounding yes. Don't like that color. Is a resounding yes, because we have x minus 4 in the denominator and it doesn't cancel. Statement 1 is true. Statement 2, there's a vertical asymptote at x equals 5. Well, that's true for the same reason that we had one at x equals 4. It's true because we have an x plus 5 in the denominator, and the 0 of x plus 5 is negative 5. There's an x-intercept of negative 4. Well, that happens to be true because we have a lone factor in the numerator of x plus 4, and the 0 of x plus 4 is negative 4. So statement 3 is true. Now, is statement 5 true? There is a horizontal asymptote at y equals 0. Well, again, for horizontal asymptotes, we compare the degree of the numerator to the degree of the denominator. And if the degree of the numerator is less than the degree of the denominator, which in this case it is, linear over quadratic, then the horizontal asymptote is going to be the x-axis, which is y equals 0. So this is true. So the answer is 1, 2, 3, and 5 in any order that you choose to write. I usually just write them in numerical order, but you don't have to. You could write 1, 3, 5, 2. You could write whatever you want, as long as you have those 4 digits. This next question attached to this context box, it tricked a lot of you. So we start off with y equals 1 over x squared, and we're going to vertically stretch it by a factor of 3. We're going to reflect it vertically across the x-axis. Then we're going to translate it 4 units up, and we're going to translate it, my mistake, we're going to translate it 4 units left. So then we're going to translate it 4 units left and 5 units up. And I think what a lot of you did with this question to begin with is you said, well, I know that y equals 1 over x squared. I know that y equals 1 over x squared has 2 asymptotes. One is on the x-axis and one is on the y-axis. And what that means, and this would be correct, is a horizontal translation of 4 units left would put the vertical asymptote at x equals negative 4. This is the vertical asymptote equation. And a vertical translation of 5 units up would put the equation of the horizontal asymptote at y equals positive 5. Okay, let's keep that in mind. So what does the question say? The function has a vertical asymptote at Well, this is the easy part. Actually, I don't think this tricked anybody. This was an easier question. X equals -4 for the vertical asymptote, y equals 5 for the horizontal asymptote, which I guess the answer is A. I'm mistaken. It's question 2 that threw some of you for a loop. Because as soon as you see, for example, that you have a horizontal asymptote, I'm going to write this down because there's a subtle distinction here. You have a horizontal asymptote at y equals, we said it was shifted up 5. Your brain says, well, that means y cannot equal to 5. Now, first of all, that happens to be a true statement in this case, but I don't know if you recall, graphs can cross horizontal asymptotes. They don't have to be a non-permissible value. However, it will be a non-permissible value. And then what many of you said is that C was the answer for the range of the new function. Because if y equals 5 is the horizontal asymptote, then y cannot equal 5. Except when you constructed this image in your head of the asymptotes, you forgot that we were dealing with y equals 1 over x squared, which lies entirely above that horizontal asymptote. The range of this function, y equals 1 over x squared, is y is greater than 0. When we reflect the function vertically, that's going to change it to y is less than 0. So this would be y equals -1 over x squared. That would be the reflection. To boot, it's stretched vertically by a factor of 3, but all that's going to do is stretch things further away vertically from that asymptote. When we shift that asymptote up 5, then what you're going to be looking at, and I hope the light has gone on for everybody at this point, but when we shift it up 5, over here is the asymptote y equals 5. This thing is going to look like that. Now, it also shifts, I think, to the left 4. But, I mean, if I shift it all to the left 4, it's going to be over here. I'm going to have a horizontal asymptote at y equals 5 and a vertical asymptote at x equals -4. But that's not relevant to the range. Anyway, looking at the solution here, that means that for question 7, D is the correct answer. And we have one last question, which is probably the easier one because it was just building on what we already learned the previous day, which is that a rational function, when everything is in factored form, those factors tell us about individual features. For example, if you have a hole or a point of discontinuity, if you want to sound a little more sophisticated, you have a hole at -3, comma, whatever. It happens to be, looks like 2.5. It doesn't matter. But if you have a hole at -3, that means you must have an x plus 3 somewhere. So I'm seeing x plus a number, x plus a number. I'm going to write this as x plus 3 on the top as the left factor, x plus 3 on the top as the right factor. The order doesn't matter. I'm just writing it so that it matches what is in the question. You have learned that when you have and I will darken this up for you, when you have a vertical asymptote, in this case a vertical asymptote at x equals 1, that you need a factor in the denominator whose 0 is 1. So we have x minus 1. And the thing that a few of you missed is the x-intercept. If the x-intercept of a rational function is, for example, 7, then you need a factor in the numerator whose 0 gives you that x-intercept. So we have x plus 3, x minus 7, x minus 1, x plus 3. When you match those letters A, B, C, and D to what I've written, you get 3, 7, 1, 3. I hope that that's been helpful. Have a great evening, and I will see everybody tomorrow, I hope. Take care.